Okay, hello everyone. So today we will do something new. So last time we have finished the algorithms of sorting. So today we will go to a new field, that is searching algorithms. So first we'll talk about what are they. So actually searching algorithms are essential tools in computer science used to locate specific items within a collection of data. These algorithms are designed to efficiently navigate through data structures to find the desired information, making them fundamental in various applications such as databases, web search engines, and more. So, actually searching algorithms are just used to find the information you want in a data structure. So we'll first begin with the simplest searching algorithm, that is linear search. So actually what you do in a linear search is to traverse the whole sequence one by one. So for example, we have an array here. So it contains elements 10, 50, 30, blah blah blah, and when we do the linear search algorithm, we'll just start from the first index, that is 10 here, and after for example, if the element we want is 60, so we'll first check this element. So it is not 60, so we'll just move on to the next element. So 50, 30, 70, 80, then 60 until we find the element we want. So this is linear search. And now we'll talk about binary search. So binary search is defined as a searching algorithm used in a sorted array by repeatedly dividing the search interval in half. The idea of binary search is to use the information that the array is sorted and reduce the time complexity to O log n. So actually binary search is a very commonly used searching algorithm that we will use in computer science. So now I will talk about how this binary search works. So actually we have two indexes. The first is low and another is high. So we'll use this index to mark the locations, and then each time we'll look for the element in the middle of these two indexes, that is low plus high minus low divided by 2, or you can also define this middle index by high plus low, then the sum divided by 2. So this is how binary search algorithm works in detail. So first you will compare the middle element of the search space with the key. So if the key is found at the middle element, the process is terminated because you get the index of the element you want. And if the key is not found at the middle element, you will choose which half will be used as the next search space. So we can look at here. For example, if we find that the element in the middle of the array is smaller than the index we want, so if the array is sorted, we will know that actually the left part of the array is all smaller than the index we want. So we know that the element we want is not in this part of the array. So now we know that we only need to look for the element in the right part of the array. So that is how it works. And now we'll choose another half and do the same thing again. So we'll just adjust the begin index, and then we'll just calculate the middle index again and do the searching stuff. So we'll use this example to illustrate in detail how the binary search algorithm works. So for example, if the element we want is 23. And here we have a pre-sorted array. So first, low, the beginning index is 0 and the ending index is high is 9. Then we'll calculate that 0 plus 9 divided by 2 is 4 in Java because you will get an integral. And then we'll find the element at index 4, that is 16. So now we'll compare 16 to the key 23. So we'll find that 23 is greater than 16. And this time we'll know that these elements are not the elements we want. So now we'll set this low index to 4 plus 1, that is 5. So now low is 5 and high will remain at 9. Now 5 plus 9 is 14 and we'll look for the element at index 7. And now we'll know that 56 is greater than 23. So in this way we'll know that actually the element we want is inside the interval between 23 at index 5 and 7 minus 1, that is index 6. Okay, so actually we'll just adjust this. We'll just adjust this high index again. So low is 5 and high is 6 this time. Now the new middle value is 5 plus 6 equals to 11 divided by 2, that is you'll get 5. And then you will know that middle index is 5 and you will compare 5, the 23 to the key 23 as well. Know that according to the procedure 23 is equal to 23 and you find the element you want and the process is terminated. So after this binary search process you will know that the element 23 is at index 5 of the element of the array. And here are the Java programs in order to implement this binary search algorithm. So actually there are two ways to implement this binary search. So the first is using iterative methods. So actually you are using a while loop to finish the process. So first you will define the left index and the right index. Okay. Then you will declare while loop. So the condition it will be L is less than or equal to R. So if L is equal to R, you'll find that this will be the last comparison you make. So if you still do not find the key inside the array, then perhaps it is not in the array, so it will be terminated anyway. Then you will calculate the middle index. So it is L plus R minus L divided by 2. Or you can also write L plus R and the sum divided by 2. So then we'll do the comparison. So actually this is pre-written in a method called binary search by us to do the procedure of binary search. So this will provide more convenience for us to return the value. So if we find the key, we'll just return the index of the key. So if the key is the element is less than the key, so we'll just set the left index to middle plus 1. So actually you can also set it to the middle index, but you don't have to do this because actually you already know that middle is not included in the range. So if it is not equal to the key or less than the key. So it will be greater than the key, so we'll write. Else we'll set the high index to middle -1. So after finishing this while loop, if we did not return anything, we'll know that the index is the key is not inside this array, so we'll just return -1 to represent that we did not find the key. And here is the thing that you will have in the main method to call the method binary search in order to perform this searching process. And the next way you will implement this binary search is to use recursion. So actually we will not have the while loop, but only the method called binary search. So if the right index, this element, is greater than the left element, we'll perform this binary search, or we'll just return -1 to end to terminate the process. So we'll do the same thing to calculate the middle index, and if we find this key, we'll just return it. That is also the same. So if we did not find this key at the middle index, if we find that the element is greater than the key, so we'll just perform another binary search. So inside this binary search, we'll have the same array, but we have different index of L and R. So L remains L, and R will be assigned a new value here, we middle -1. So here's an array. So first we do binary search here, here, and middle is here. Then we'll find that this part is not the range that the key will be inside. So we'll just ignore this part, and we have the same array to pass into this method, and this time the high index will be this place -1, for example this place. Okay, so when we pass in this array, it will only start from this and at this place, so it will do the searching for this part of the subarray. So actually this is how recursion works. And if we have the element smaller than the key, we'll just do a similar process operation. We are just passing middle +1 as the left index and R as the right index. So these are the two ways that you can implement this binary search using Java code. And this will be pretty the same for the main method that you use to call this binary search. And here are some drawbacks of binary search. So the array has to be pre-sorted if you want to do this, or you will not be able to identify the correct range of the rest of the elements that your key might be in. And the binary search requires that the data structure being searched to be stored in contiguous memory locations. So if you perform the binary search, for example here, perhaps you will know that index 4 must have a value after index 3, for example. If you have nothing here, you will not be able to store it to perform the binary search. However, it also have a lot of obvious advantages. That is, it will be very fast because it is O log n. time complexity, and if you only do linear search every time, it'll be O n that is constant to perform the task. That is very slow for a large data structure. And that's all for today's activity. Thank you.